seen as a pair of bright stars visible in daytime, and at night they would shine as bright as the full moon, and our sun would appear as a distant star. Unfortunately, the nearby red dwarf is known to emit flares or intense bursts of radiation and energetic particles up to 1,000 times stronger than the flares on our sun. This could be problematic for any potential life on the surface of Gliese 667cc, as the planet is located close to its flaring host star. And the strong magnetism of the red dwarf may cause star spots that can reduce the energy output of the star by up to 40% for months, which, combined with the lack of ultraviolet light emissions, would be another issue for the formation of life as we know it. Living on Gliese 667cc would be nothing like what we're used to, also because of how massive it is. The higher mass of the exoplanet means different gravitational acceleration on its surface. This world is rocky, and so the gravitational acceleration would be up to 60% higher than what we experience on Earth. A person weighing 75 kilograms on Earth would weigh as much as 120 kilograms on Gliese 667cc. In addition, a planet with higher mass could hold a more massive atmosphere, leading to higher atmospheric pressure at the planet's surface. In case it has an atmosphere similar to Earth's, the atmospheric pressure would only be a few times higher. But if the exoplanet has a Venus-like atmosphere, the pressure could be several hundred times greater, equivalent to the water pressure several kilometers deep in Earth's oceans. Despite its location in a habitable zone, Gliese 667cc may not have the same conditions as Earth. Life forms on Gliese 667cc may have to adapt to fluctuating and low light, potentially high atmospheric pressure, and frequent flares. But this doesn't mean life cannot form on such a world. We've already seen examples of remarkable life adaptability on Earth. The two other potentially habitable planets are almost identical. Gliese 667ce and Gliese 667cf are both located farther out from their planet star, meaning they receive less energy. This could make them too cold to support life as we know it. But unlike with GJ667cc, having a thick atmosphere would be beneficial for potential life on these planets, as it would trap heat and maintain favorable temperature conditions. Spotting 3 such worlds in the habitable zone of the same planetary system is extremely rare, but 4 is almost unthinkable. According to one study, 5 planets in the Gliese 667c system are estimated to receive solar radiation ranging from 20 to 200% of the current exposure of Earth to the Sun, which makes them all candidates for potential habitability. But there are other factors in play. Scientists have determined that for a planet with a mass equal to Earth, the habitable zone around Gliese 667c has 2 boundaries. The inner boundary lies between 0.095 and 0.126 astronomical units from the star, while the outer boundary lies between 0.241 and 0.251 AU. Any planet orbiting within these distances from star C may be able to sustain life, as it would have the right conditions for liquid water to exist on its surface. If a planet is too close to its star, the heat will cause water to turn into vapor and escape, making the planet uninhabitable. This happens because water vapor is a greenhouse gas, which can trap heat and cause temperatures to rise to intolerable levels. Only the planets at the inner edge of the habitable zone with a larger mass are more resistant to the moist greenhouse effect. On the other hand, if a planet is too far away from its star, like the outermost Gliese 667g, it risks being covered in ice. While gases like CO2 can warm the planet and prevent this, too much CO2 can actually cool the planet down by reflecting light away. So there's a limit to how much CO2 can help warm a planet. In 2013, astronomers made an announcement that Gliese 667c has a minimum of 6 planets, and there's a possibility of a 7th planet designated as GJ667ch. Although highly controversial, the exoplanet could be the smallest one found so far around star C, with a mass of at least 1.1 times that of Earth, located just between the planets C and B. Because of its mass and proximity to the parent star, the planet H would be too hot for any life to form. The planets F and E are confirmed to orbit in the habitable zone, and although the estimated location of the planet D is outside the outer edge of the habitable zone, its orbit is still uncertain. This means Gliese 667, CC, CF, CE, and possibly even CD are all potential habitable worlds. The discovery of densely packed planetary systems around M-dwarf stars, such as Gliese 667c, points to the existence of numerous populations of planetary systems out there, each with several potentially habitable planets. And since M-dwarfs account for more than 70% of all stars in our cosmic neighborhood, the number of such promising planetary systems in our galaxy is likely to be much greater than ever thought. Instead of searching for a single potential habitable planet among 10 stars, scientists can now focus on one star to find multiple Earth 2.0 candidates. As new and advanced telescopes are being developed, our ability to uncover the mysteries of the universe is growing at an exponential rate. What star system would you like to hear about next? Sound off in the comments. Stay tuned here to be the first to hear about the next big discovery in the cosmos, and make sure you click the super thank you button if you enjoyed the video. Thanks for watching.